Hello, Professor. My name is Ma Jiaying. My study is titled A Comparative Study of Machine Learning Models for Customer Chain Prediction in the Telecommunications Industry. I present this study as follows. First, why chain matters. Then, how the models were built, what the results showed. And finally, how the findings can support customer retention decisions. Before going into the details, this slide shows the overall structure of the presentation. I will start with the background and research focus, then briefly cover the literature framework and research gap. After that, I will explain the methodology and the model setup. The main part is the findings and model comparison, followed by discussion, concurrent, and future work. In Chapter 1, the problem is not only technical. This is a business analytics problem. Telecom customers can switch providers quite easily, especially under flexible contracts. When they leave, the company loses current revenue, future revenue, and customer relationship value. At the same time, telecom companies already have useful data, such as contract type, 10-year charges, and service subscription. The challenge is to process these variables properly and evaluate the models fairly, especially because the dataset has more non-Chuan customers than Chuan customers. The study has five objectives. First, it identifies customer-related factors associated with chain. Second, it develops five models. Third, it evaluates the models using several metrics, not accuracy alone. First, it compares the predicted performance of logistic regression, decision tree, random forest, support factor machine, and naive Bayes. Finally, it discusses how the best model can support retention strategy. In simple words, the study asks who is likely to leave? How can we predict it? Which model is better and what can a company do with the answer? For Chapter 2, I keep the literature review concise. Prior studies show that chain prediction is connected to customer relationship management and business value. Machine learning can classify customers into chain and non-chain groups. However, accuracy alone may be misleading because chain data is imbalanced. Also, many studies use different pre-processing and evaluation settings, which makes direct comparison difficult. This study addresses the gap by applying the same dataset, same pre-processing workflow, and multiple evaluation metrics. Chapter 3 explains the methodology. This study follows a quantitative predictive analytics design. The workflow starts from data import and cleaning. Then leakage-related fields are removed. After that, categorical variables are encoded. The data is split and scaled. Five models are trained, and finally the results are evaluated using multiple metrics and the confusion matrix. The important point here is consistency, or five models are compared under the same workflow. The original dataset contained 7,043 records and 33 variables. After cleaning the total charts variable and removing 11 missing records, the final dataset contained 7,032 records. The target variable is chain value. After one hard encoding, the number of input features became 31. The dataset was split into training and testing sets using an 80 to 20 ratio with stratification. The five selected models represent different classification approaches, so they provide a useful comparative view. Now I move to chapter 4, the findings. The data shows a moderate imbalance. 73.4% of customers are not trying, and 26.6% are trying. The described analysis identifies three important factors. First, month-to-month contract customers are more likely to join. Second, customers with shorter tenure are more likely to join. Third, customers with higher monthly charges are more likely to join. These findings suggest that trend is related to flexibility, loyalty, and perceived value. This slide compares model performance. Logistic regression achieved the highest accuracy, F1 score, and ROC-AOC. Decision tree had a slightly higher record than logistic regression, but a weaker overall balance. Random forest and SVM performed similarly in accuracy, but their record was lower. Naive layers achieved the highest record, which means it identified many actual joint customers, but its precision and accuracy were much lower. Therefore, the best overall model is logistic regression. The confusion matrix makes the business meaning clearer. False positive may waste the retention resources because the company may spend money on customers who are not actually likely to leave. False negatives are also risky because the company may miss customers who are about to join. Logistic regression gives a more balanced pattern. Naive bias catches more chain customers, but it also creates many false positives. Therefore, logistic regression is selected as the most suitable model in this study. In Chapter 5, the discussion focuses on how the findings can be used. For month-to-month customers, telecom companies can provide loyalty offers or encourage contract upgrades. For customers with short tenure, the company can strengthen onboarding, service support, and follow-up. For customers with high monthly charges, the company can review the package and provide more suitable value-added services. The predicted result can help companies prioritize limited retention resources. To conclude, this study compared five machine learning models for telecom customer churn prediction. The key factors associated with churn were contract type, tenure months, and monthly charges. Logistic regression was the most suitable model because it achieved the best overall performance in accuracy, F1 score, and RLC. The business value is that companies can identify high-risk customers easier and design more targeted retention strategies. Future research can use richer behavioral data. Stronger models such as XGBoost and lighter GBM and imbalance handling methods such as smooth and threshold adjustment. And that's all. Thank you for listening.